Hello everyone, welcome back to my channel. So today we are going to discuss another problem. But before going forward, if you have not liked the video, please like it. Subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is subsequence. We'll be given two strings, S and T. We need to return true if S is a subsequence of T. Fine. Otherwise we have to return false. So a subsequence is what? A sequence is a new string that is formed from the original string by deleting some of the characters without disturbing the relative positions of the remaining characters. For example, here ACE is a subsequence of ABCDE. Why it's a subsequence? Because A, C, E, they are in correct order and we are deleting like B and D, so and we are getting this AC. While AEC is not. Why AEC is not? Because see, over here, if we have A, B, C, D, E, so A, C, E is a subsequence. A, C, E. Fine. But A, E, C is not a subsequence. Why? Because A is there, but then we get E. After that, there is no C. So these letters should be in the same order in the string. If we will not do it like this, that okay, we have A, we have E, and we have C, so it's a subsequence. No, the order should be same. That is, first A should come, then E should come, and then C should come. Fine. So for example, if the string was like this, A, B, C, D, E, and after E there was C, then A, E, C will be a subsequence because we get A, then we get E, and then we get C. Fine. So this is a subsequence, right? We have to tell whether this ABC is a subsequence, that is S is a subsequence of T or not. Fine. This is we need to tell. So if S is a subsequence, we will have to return true. Otherwise, we have to return false. Fine. So let's see for this test case. So here, let's take this first test case. See, over here, our string is this: A, H, B, G, D, and C. Right? And over here, we have ABC. So A is there, then we have B, and then we have C. So ABC is a subsequence. It is a subsequence of this. So output will be true. Right? Let's see the other test case. So here we have AXC. This T string is same. S string is changed to AXC. So over here we have, in place of B, we have X. Right? So see, let's check whether this is a subsequence or not. A, X, C. So see here, A is there, X is not there. Right? So when X is not there, there is no need to look forward because only this letter we are not able to find here. So this is not a subsequence. This is not a subsequence because X is not present here. Fine. I hope you understood the problem. So in this case, the output will be false because this is not a subsequence. So here output is false. Fine. Some constraints are given that S length will be, that this string's length will be up till 100 only. So it will not be greater than 100. T's length could be 10 raised to power 4. And S and T will always have lowercase English letters, right? Small case. And there is a follow-up also that we will discuss afterwards. But let's see how we will approach this problem first. Fine. Okay. So one approach, guys, see, one approach which directly comes into mind when we have when we have this subsequence problem, one approach which directly comes into mind is that we can use dynamic programming. That is, we can just simply check whether this is a subsequence of this or not. like this S is a subsequence of T using dynamic programming, using DP. But that will be O of, let's say this has length M and this T has length N. So that approach using dynamic programming will be Mn. Fine. So this we can improve from this, right? We can improve from this. So dynamic programming approach we will not discuss here. Although we can have dynamic programming approach we can use over here. There's something called as longest common subsequence. Longest common subsequence. So that we can use here. So if we over here, see what we can do is we have B here, right? So we can find longest common subsequence of these two strings S and T. So if S is a subsequence of T, longest common subsequence will come out to be S only, ABC, ABC between these two. So if longest common subsequence is coming as S string, then means this is a subsequence. Fine. This approach you can use, but that will be O of Mn. So we will not discuss because that's not optimized, right? Let's discuss another approach which is a better approach, right? It's not the best approach, but let's see the better approach now. If you want to know about dynamic programming approach, you can refer videos. There are a lot of videos. You can check how longest common subsequence you can use here. Fine. Now let's see the other approach. Okay. So see, what we have over here is we have this string A, H, B, G, D, C. This is T, right? We have to find whether ABC is a subsequence of this or not. So what we can do, we can check whether ABC letters are there in this string or not and in the correct order. So first of all, condition should be they should be present in T, and second should be they and in the correct order, in the correct order, that is C. For example, over here I am changing this to ACB, changing this to ACB. So then this is not a subsequence of this. Why? Because although we have A, although we have C, and although we have B, but after A we have to get C. So C will come here, and after that there is no B, right? There is no B. So first of all, every letter should be present. First of all, like if remember in AXC, X was not present in this now, so that condition became false. Over here, in this case, every letter is present, but not in the correct order. So A, C, and after C there should be B. There should be B, but there is no B. Fine. So these two conditions should be there in order to it S to be subsequence of T. Now what we can do over here is we can just check whether there are all letters or not, and in the correct order as well, right? In the correct order. See, what we can do is we can have a variable A, let's say A is equal to 0 initially. Fine, we will start comparing characters of S and T. Fine, we'll have a pointer in the T, we will iterate in T string, and whenever we get a similar character to S, we will update our counter. You will understand how we are doing. So see, first of all we'll start from here. Let's say this is our I, and this A is I is pointer of T, means I is will be iterating over T, and A will be iterating, this A variable will be iterating on S. So initially we have I here at 0 index. So 0, 1, 2, 3, 4, 5. So we will check if T of I, this is T of I, right, is equal to S of A. So T of I is A and S of A, here this is 0, 1, 2. So S of A is also A, right? They are same, A. Here it's A pointer. Fine. So they are same. Hence we will increment A++. That is we have found this one first letter in this T. So we can just increment our a pointer. So a will come here. That is, it will increment. Fine. And I will always increment. So I will now be here. Now again we will check. H is equal to C? No. H is not equal to C. So what we will do, we will do nothing and we will just move I forward. We will move I forward. Then we will check whether T of I, which is B, is equal to C. No. Fine. So we will again move forward. So basically we are checking when we get C here. If we get C or when we get C in the T string. So now I will come here. Let me do one thing. Let me change the test case. So here we can have the correct one so that we can understand how it's working. So BC, right? ABC. Now when we so here A is here, right? And I is here. So here now B is equal to B, right? B is equal to B. That is T of I is equal to S of A. So what we will do again? We found another letter. So A we will increment and I though we will always increment. I we are always incrementing. So I this will come out come here. A will come at second index. We have found two letters. See, we have found two letters A and B. Now what will happen? G is not equal to C. So go ahead. D is not equal to C. Go ahead. Now C is equal to C. So we found the third letter also. So we will increment A and I will go out of bounds. So we have traversed the T string. Right. And after traversing T string, if this A is equal to, if this A is equal to the length of this S string, fine. If it is equal to the length of S string, means we found all these letters in the correct order. We found these letters in the correct order. And this here, if this is the case, then we can return true. We can return true. Fine. So let's discuss one more test case regarding this, so it will be more clear. Let's say we have, this is AHBGDC. We have AHBGDC. Fine. And now let's take that test case. We have this one. Let's say S is equal to AXC. Fine. AXC. And this is our T string. So first of all, we'll take two variables. I will point here. This is 0 index, 0, 1, 2, 3, 4, 5. And this is 0, 1, 2. And A variable will be here initially at 0 index. Fine. So we will check again that if T of I is equal to S of A, do I A plus plus. Fine. A plus plus. So see, A is equal to A. Fine. So we will increment this. This will come here. And I though will always go ahead. Now H is not equal to X. Fine. So we'll go ahead. B is also not equal to X. Go ahead. G is also not equal to X. Go ahead. D is also not equal to X. Go ahead. And C is also not equal to X. So we have traversed the T string. And after that, A is not equal to length of S now. Earlier, if you remember, A was coming to be equal. Fine. A was coming to be equal to length of S. But now here A is not equal to the length of S. A is 1 and length of S is 3. Means we have not got the all letters. We have not got all letters. Hence it's not a subsequence. So here in this case we can return false. Fine. So see, output is false. So I hope you understood this approach. Let's look code once for this. Very easy code. So we have we have this. So see, these are edge cases initially. These are edge cases that see, if we have S as empty string. So empty string is a subsequence always, right? So we do not care what is T. If S is empty string, S will be a subsequence of T. So if s is a empty string, we can just simply return true. Fine. And if s is not empty but t is empty, if s is not empty and t is empty, then obviously s cannot be a subsequence of t because t is empty only. Then we'll return false directly, right? And if there are one letters, like if there are one letter in s and t, so in s also we have just like, so let's say s is only a and t is also just a, so there are only one letter, we can just simply compare these letters if they are same, and if they are same just return true, otherwise return false. Fine. This is one thing. Here there is no need for this. So now we are taking a variable and we are iterating on the t string. Fine. And if a is greater than equal to size of this, we can return true. And over here, if they are equal, just increment a. So I think simply we can return false from here also. Let's check this thing if this works, because then there is no need for this. No, it's failing now. So ABC, yeah. So see, fine. Okay. So see, now after this for loop, we will check whether A is equal to S of size. Fine. If you remember, we were checking this, right? If A is equal to len of S, right? If they are equal means we got all the letters, so return true, else return false. Fine. So we can remove this condition from here. Let's check that. Okay. Fine. So that's working. So we can just simply, in for loop we are having, if they are equal, just increment A. Otherwise, I will be always incrementing. Fine. So this is one approach, guys. See, this is one approach. Now time complexity for this will be what? We are just we have single loop, right? This is single loop which we have, and it is running t size, like length of t string. So if t string, let's say if t string, uh, length of t string is n, so time complexity will be O of n, because there is one for loop. Now let's see the follow up. So I hope you understood till this. Follow up is that they are saying that suppose there are lot of incoming s, that is this s string, which we have to check whether it is a subsequence of t or not. If there are a lot of these incoming s, so there are s1 s2, a lot of s are coming, so what we will do is, we are given and k is less than like greater than 10 raised to power 9, means there are 10 raised to power 9, more than 10 raised to power 9 s strings coming. So there are, let's say, 10 raised to power n s strings. So for all these strings we need to check whether they are subsequence of t or not, whether they are subsequence of t or not, and you want to check one of two, their subsequence. In this scenario, how we can change our code? So see guys, right now till now our time complexity is O of n, and n could be what, n is the length of t, right? And length of t could be 10 raised to power 4 maximum. Now let's say if there are k strings coming, so for one string, for one s string, time complexity is O of n. For k strings it will be k into n, right? So time complexity will be, in that case, it will be O of k into n, where k is the number of strings which we are getting. So, right, so that could be greater than equal to 10 raised to power 9. So let's take 10 raised to power 9 only. So 10 raised to power 9 multiplied by n was 10 raised to power 4. So this is a, will get time limit exceeded, right? We'll get time limit exceeded in this case. So we have to improve this time complexity O of n. We have to improve it somewhat. Fine. Okay. So now let's see how we can improve this. So now we'll discuss the second approach. Let me write the test case first. We have T as um, AHBGDC. AHBGDC. Then we have S as ABC, right? BC. So now see guys, what we can do in second approach. What were the two conditions? First of all these letters of S, all the letters of S should be in T. This was one case, should be in T. Second, they should be like S letters should be correct order. In correct order. So for example, if in place of this B we have X. So X is not in T, right? X is not in T. So simply we can return false. That X is not in T, hence this is not a subsequence. This is one case. Fine, this is one case. But let's say we have something like this. We have ACB. So we will get A, we get A. But here C is also in the T, right? C is also in the T. So we'll get C also. Now when it comes to this B, B is also in T. B is also in T, but ideally this B should come after C, right? Because we are taking C first and then it should come after B. So from this now we can get to know, we can think that we need to somehow maintain what was the previous index of the previous letter. Like what was the index of the previous letter. So when we are at this B, we need to know what was the index of this C. So for this index of C will be 5. So when we are finding this B should have an index greater than 5. That is, it should be after C. So here B has index 2. B has index 2, right? Which is less than 5, not greater than 5. So means there is no B after C. So this is not a subsequence. Fine. This is the approach which we will be following. Let's see in the I hope you understood. Let's see, let's dry run once. So we can see what we will be doing here is we have this T A, what was that? AHBGDC, right? AHBGDC, and we have S as ABC. Now see, what we can have is, we will first of all we have to check whether these letters are in T or not, right? So we can use Hashmap for this. We can use a unordered map, or you can say Hashmap for this. So searching in map is average case is O of 1. So that we can use. So here what we are going to do is we'll be storing all the letters of T in the here. Fine. And like all the letters of T as key, and the indexes and their indexes as values. Index. So see guys, there might be a case that let's say here we have in place of G now I am taking A. So we have A here. Fine. So let me, yeah, so what we will do is we will first of all iterate on this T and we'll be storing all the letters in this map. So for this let's do indexing 0, 1, 2, 3, 4, 5. So for this first of all A will come and there will be a list, and this list will store all the indexes of this A which is occurring in T. Right now it's 0. Then we have H is 1. Then we have B is at index 2. Then again we have A, right? So A is at index 3. So 0, 3. 0, 3. Then we have D. So D will be at index 4, and then we have C at index 5. Fine. So see now what we will do. Now we will iterate on this string S. Now we are iterating. We'll take I pointer and we'll be iterating on this string S. So first we have to check what were the two conditions. We need to check letter is in T or not. Letter is in T or not, and the index of the letter should be greater than previous index, previous letters index, right? Should be greater than previous. So also we'll be taking a previous variable. So here I am taking a previous variable, previous, and I'm initializing it with -1 in the starting. So see guys, now what we will do, we will check first whether A is in the map or not. That is, A is in T string or not. A is there. A is there. So that's fine. This condition is fine. And index of letter should be greater than previous. So A's index should be greater than previous. So for this we just need to check whether there is an index of A which is greater than the previous, which is greater than this previous. So A is at 0 index. So that is fine. So for checking this now, we can use upper bound. We can use upper bound function in C++. What will upper bound do? Upper bound, we will provide a range to the upper bound. So we will provide this array to upper bound 0, 3, 0, 3, and we will ask upper bound to find whether there is a value in this array which is greater than previous, which is greater than previous. This is what upper bound does. So upper bound will find a value which is just greater than this previous. So just greater than this previous is 0, right? So we will get this 0. Fine, we'll get this 0. Fine, so I hope you understood. So now we got A, and we previous index now will update to 0. So now because A was found at 0 index, right? Now let's go ahead. Also let's do one thing. Yeah, I think yeah, that's fine. So yeah, now I will come here. Now we have to find whether B is in, first of all, if B is in the map or not. So B is there. B is there. Then we will check whether index is greater than the previous or not. So B's array is 2. Like this is the B's, all the occurrences of B. All occurrences of B. Fine. So what we can do is, yeah, that's fine. Okay. Let's do one thing, yeah, but like all the changes will. So let's, yeah. So see, B is this, right? Now we will check whether there is a index, that is we can use upper bound to check whether there is index here in B, in this array, which is greater than previous. So previous is 1, previous is 0, right? So 2 is greater than 0. This is the first occurrence which is greater than 0. So we found occurrence of B which is greater than A's occurrence. Since this is fine. So we go ahead. Right. Now C. Now we go to C. So first we check whether C is in map or not. C is in the map, and then whether its index is greater than previous. So previous will update to be 2 because B was at 2, right? C is 5. So we will check whether there is an index of C, that is occurrence of C, which is greater than previous. Yes, there is 5. So this is fine. Hence ABC is a subsequence of this T string. Fine. Now let's take another test case. So let's say I am taking over here like this. We have ACB. Fine. So A will work fine. Previous will update to 0 in that case. Fine. So in this case, I'll highly recommend just try run once for this ACB, how it will work and how it will return false. Fine. So see, let's see the yeah, let's see the code for this. So see, the code is, first of all, we have this map. We are creating this map. See, we are creating this map for this T string. So all the letters we are storing along with their indexes. So this value will be a list, because there could be more than one occurrence of letters, so we have to store all the indexes. So that's why we are making a list. So value will be a list, right? So if we dry run also, let's say dry run for this ACB. See, for A, 0 will found, so previous will get updated to 0. Then for C, we will have this 5, so we will check whether there is occurrence greater than 0 of C. So yeah, there is 5, so 5 will get updated as previous. Now we'll go to B. For this B, there is 2. Now previous is 5, but there is no occurrence of B which is greater than previous. B is occurring at 2, which is not greater than this 5. So upper bound will give you, the iterator at the end. Fine. This upper bound, because there is no value which is greater than this previous in this array. Previous is 5. Hence, when we get the last iterator, here last iterator means we did not found any occurrence of this letter B which is greater than the previous. Hence, we will return false from there. We'll return false. Fine. Let's see the code. So see, this we have done. In map we stored. Now we are iterating on each letter of S. So we are going on each letter of S, and we are checking. First we are checking whether it is in the map or not, whether it is in the HG map or not. So if it is not in the map, that is iterator has reached the end of the map and it's not there, means it's not there. So just return false. For example, AXC. So X will not be in the map, hence just return false from here. Fine. Otherwise we are finding upper bound of starting from this, we are storing this it second means this array, because if iterator is here, then this is first and this is second. So we are storing that in a vector, and we are finding the upper bound of that previous, like whether there is a value in this vector which is greater than the previous. So we were doing that only, that whether there is occurrence of B which is greater than any index where is greater than previous. And if it is reached the end of the vector, means there was no occurrence, that is here 2, there was no occurrence, so it reached the end because there was nothing greater than 5 previous. Hence we can return false. Otherwise just update the previous. So vector of position, whatever that index is, just update it in previous. Fine. So at last you can return true once this loop is over. I hope you understood this approach. Just try run once, you will better understand. So see, let's see what's the time complexity for this approach. So for this approach, for one string, time complexity will be, see, we are iterating in S. So if M is the length of S string, so it will be O of M multiplied by, we have this upper bound, right? Upper bound has log of n, log of n time complexity, and yn, it will be log of something. So what it will be, see, in the worst case it might happen that all the letters are same. A is there in the T, so A is in the T. So if we store A in the hash map, so it will have all these indexes 0, 1, 2, 3, like that. So at max, this vector in which we are finding, so we are finding in this vector only, this one which is the list. So at max that could have length as n, so it will be m log n. So see, in the earlier approach, 2-pointer approach, the complexity was O of n. We were using this loop, we were iterating on T. So if T's length is n, so it will be O of n. And if we have k, so it will be k multiplied by k. So for this it was going beyond 10 raised to power 9, right? For here it will be, see, m could be maximum 100, because in the problem they have given that here S could be at max 100 length. So 100 multiplied by log of n. N could be 10 raised to power 4 multiplied k could be 10 raised to power n. So this approach is much better. This approach is much better than this approach. Fine. So I hope you understood the problem and the approach. Let me know in the comments if you have any doubt. Code will be in the description. And if you found the video helpful, please like it, subscribe to my channel. I'll see you in the next video.